go over any questions that you guys have and kind of just get ready for the test tomorrow. I think I'm just going to kind of go page by page here. If there's anything on each page that you have questions on, just let me know. The in behavior test, what I'm going to tell you here is just don't always rely on your picture. And when you have a problem like that, sometimes you can look at the picture and kind of get an idea of what it looks like. Sometimes they're going to give you a polynomial that sometimes is hard to look at. Just remember this, two things you got to remember. Number one, if it's odd, it's going to be going opposite directions, okay? Odd and opposite is what you want to remember here. So 3, 5, anything like that. Make sure you look at the highest degree, okay? And then if it's odd, which 3 is, then they're going to go opposite direction. So immediately I can eliminate B and D. Okay, if it was even, if it was like x to the 4th as my highest exponent, it's either going to be up, up, or it's going to be down, down. Okay, if I have a negative in front, okay, if it was even, it's going to go down. If it's positive, it's going to go up. If it's an odd exponent like this one, just think of like a linear equation. If I have a positive slope, it's going to rise as it moves to the right. So it's going to start down and it's going to end up. But if it's a negative, think about it like if I have a negative slope, it's going to start up here and it's going to end up down here. So those are the ones that you kind of want to think of. So this one would just be like a negative slope, right? Because we have an odd exponent. So it's going to start up and it's going to end down. And just kind of think about some other situations. And can you put it into the calculator? Maybe. It just kind of depends on the polynomial that you have. And sometimes you don't get a real good look at the picture. A few people asked me about number 3 yesterday. Just make sure you set all 3 of these equal to 0, okay? As long as it has an x on it. If this was just like a 3 out here in front, we wouldn't need to set it equal to 0. You can't really set 3 equal to 0. But as long as it has an x on it, we can set it equal to 0. So essentially this would be like my GCF. And then these are 2 separate factors, and then my exponent is also the multiplicity. So make sure you identify the multiplicity as well. Find the zeros, state the multiplicity. Okay, number 4 is a little bit different than the one that was on the quiz. The one on the quiz, they gave us the meters, how far it had traveled, and we had to find the time. That's quadratic equation. So this one, though, gives me the time. Gives me how many seconds have passed, and so it wants to know how far did this object move after so many seconds. So after 8 seconds, how far has this object moved? So I'm just going to take 8, I'm going to plug it into the function and figure out what my distance is. Okay, so it's a little bit easier than maybe the one that we did on the quiz. Any questions on that page? Okay, number 6, you could plug this one right into your calculator and kind of get some of the things. If I want to know what my zeros are, I can also find the zeros really quickly even before I graph it. I set each factor equal to 0, kind of like we talked about on the one on the first page. I set each one of these and solve them. Divide by 2, subtract 2, add 1. Those would be my 3 places that it's going to cross or touch the x-axis. And then I just need to draw a sketch. And you can definitely use your calculator here. All of those have a multiplicity of 1. There's no multiplicity of 2's here. So there's not going to be any bouncing or anything like that off the x-axis. On number 7, synthetic division, we're doing that quite a bit. Just make sure all of your exponents are accounted for. So if I start with degree 3, make sure as I work my way down that every exponent has been accounted for, 3, 2, 1, 0. Also make sure that if this is a factor, then we always do the opposite. Okay, those are just some common mistakes that are typically made with synthetic division. So -1 is the number I want to put in my box there. Okay, on number 8, I know that it says synthetic division, and you can definitely use synthetic division here. I'm also okay, we've talked about doing this a couple of different ways. This is what we call the remainder theorem. So the remainder would be my answer, okay? And you don't have to rewrite the entire polynomial. Some people asked me that yesterday. All that we're looking for here is what would be the value of f of -2. I also could just take -2 and plug it into the function, okay? And I'm totally fine if you want to do it that way. So you can either take -2 and plug it in, or you can do synthetic division, and the remainder would be your answer. Should be the same number, either way. Okay, on number 9, we had one like this on the quiz as well. We're going to solve, and then we're going to factor, okay? A lot of these are not going to factor by grouping, so I kind of showed you the shortcut would be to graph it, find out where it crosses the x-axis, state what those zeros are. We know that this would have up to 3 zeros because of my degree of 3. And I think on ones like this, most of the time, it will have 3 zeros. Find out what those zeros are, and then, like for instance, if one of them I think is 2, then the factor would be x minus 2. If your 0 is at -2, then this would be x plus 2. So the factor is always opposite of what the 0 is. But it asks us to factor it, and it asks us to solve it. So the solutions are your zeros. Your factors are your parentheses. Okay, number 10, a couple people asked me about this yesterday because when they graphed it, they could kind of tell what the zeros were. I'm going to show you kind of like, and as long as you find the zeros and graph it, do you have to show me synthetic division? I'm going to show you where synthetic division could help you and kind of use it to back up. Like the one that we had on the quiz, it helped me get that fraction. That was a 0. And so that's where synthetic division could come into play. The first thing that we're going to do here is we're going to graph this in our calculator. Use your calculator to get where you think it crosses the x-axis. And the first one that I'm going to use here is I'm going to use 1. I'm going to use x equals 1. Okay? And I'll talk about why I'm going to do that here in just a second. And so I get x equals 1 from my calculator. I can tell that it crosses the x-axis at 1. Either you could just go to your graph, or you could even go to your table, and it has a y value of 0. Okay? So either way. So I'm going to put 1 in to synthetic division. And because we just said that it crossed the x-axis at 1, we should get a remainder of 0. Okay? Now, there's 2 things that you could do here. Okay? One way is you could also probably determine from the graph that it has another x-intercept at -3. So you could do -3 at this point. Or, I was also going to show you this. If I write this as a quadratic equation, then I could factor this. And if I said what multiplies to get 9 and adds to get 6, what would we have? What multiplies to get 9 and adds to get 6? 3 and 3. Okay? So I could write this as x plus 3 and x plus 3, otherwise known as x plus 3 squared. Okay. So what I'm really looking for here x equals negative 3 with a multiplicity of 2, and x equals 1. Okay. We have to somehow account for 3 zeros. Okay? And does my graph kind of show me what's going on there? It does. And remember that if it has a multiplicity of 2, it's going to bounce off the x-axis at that point. And I'm not really worried on this one. We're not really focused on like how far down does it go here. I just want to know where does it hit the x-axis at, okay? And one of the things that's we've got to somehow state is that it only touches the x-axis twice, but we know we have to account for 3 zeros, okay? So that's kind of what I want to make sure is that we got to find all the zeros here. And so if I have 3 zeros, how do I account for 3 zeros? Well, the multiplicity of 2 tells me that this is 2 of them, okay? And so it doesn't have to cross the x-axis 3 times. The one we had on the quiz like this, we had a fraction for an answer, okay? And we could use synthetic division to get there. If I had used synthetic division at this point with negative 3, then it would get me down to x plus 3, and then I could set it equal to 0 again, and it would give me another negative 3. So there's a couple different ways that you could approach this problem, but the biggest thing for me is seeing what the graph is and then identifying what all of the solutions would be. We've got to account for 3 zeros in some shape or form. Okay, we had several of these on the quiz. Here, just got the one of them. When it says degree of 3, that just means you're going to have a polynomial of x cubed. And so when you get done, and it's just going to be a normal old polynomial. There's no i's in it or anything like that. We do have i's for our zeros, but we're not going to have i's in our answer. Okay, it's just going to be a normal old polynomial when we're done. Remember on ones like this, if it has just a regular old integer as a 0, negative 3 is just a normal old number, okay? It does not have a conjugate. The only way it has a conjugate is if it has an I and a radical. So the only two things that we have to do conjugates of is 6i and negative radical 2. So this would become negative 6i, and this would become positive radical 2. Okay? If it was a 2-part, like let's say it was 2 plus 6i, then the other 0 would be 2 minus 6i. So only the sign in between would change. So that one is just looking at the zeros that are given to me and finding out what other zeros I would have. Okay, number 13, we had one of these on the quiz as well. You're going to use the 0 that we're given. You're going to go through synthetic division. You're going to break it down, okay? And then it's going to leave you a quadratic equation. And the only way to get that, because I'm telling you right now, the one that's going to be like this is probably going to be an imaginary solution. And so the only way to get that imaginary solution is to use our quadratic formula. So that would be the one problem you would need to use the quadratic formula on. Okay, questions on that page? Anything? Okay, 15, just put it in the calculator, okay? Some of these, you can just put it in the calculator. And if we're looking for the zeros, what are we looking for? If it said find the 0, where it crosses the x-axis, okay? And typically ones like this will be pretty easy to tell where it crosses the x-axis. You can go to your table if you wanted to verify it, but you can look at the 4 solutions there, and they're all integers. And so which one of those is the best? Okay, domain. means what x values can we have and which x values can we not have. And so because we have a fraction here, what number can we not have on the bottom of a fraction? Okay, so we can't have 0 on bottom, right? And -8 is what would give me that 0. So if I set x plus 8 equal to 0, that gives me x equals -8, okay? And so we know that x cannot be -8. That gives me 0 in the denominator, which we cannot have. And so we got to figure out which one of these four takes -8 out of the domain. And so x can be anything I want it to be except for -8. And so D is the one that takes -8 out of that domain. Okay, 17, you should be able to just put it into the calculator. One thing that I would tell you here is make sure you use parentheses. You could probably do it without parentheses, especially if you use like a fraction button, but I always like to use parentheses just to be safe. Make sure you keep everything together, otherwise it might get you a little bit different graph. Okay, a vertical asymptote is anything that is on bottom. So if I factor the bottom here, sometimes it may already be factored, but if it's not, I would go ahead and factor it if you can, and then set those two factors equal to 0. So in this case, x cannot be 2 or -2, okay? So don't watch out for c. C is kind of a tricky one. We don't care about the y values here. All we care about is the x values, so it should be b. And you could see, I mean, it could be a product sum type of factoring, DOPS, maybe GCF. There's different kinds of factoring that could be done. Okay, horizontal asymptotes. When we did this, this is the one that has the 3 rules to it. This is the one that's definitely the hardest out of all the asymptotes. It's always based off a degree. And there's 3 different things that could happen. The top could be bigger than the bottom. The top could be less than the bottom. Or the top could equal the bottom. Okay, so is the degree equal on top and bottom? Is it greater than or is it less than? That's what we have to decide first. If the degree on top is bigger, then we would say that there is no horizontal asymptote. If the degree on top is less than, y equals 0 is my horizontal asymptote. If the degrees are equal to each other, then we would divide the leading coefficients. And your A and B value would be like the numbers in front of your leading coefficients. In this case, they would both be 1. Okay. But this one has a degree of 2 on top, a degree of 1 on bottom. So the top is bigger than the bottom. So this one would be no horizontal asymptote. Okay. So you just kind of have to remember the rules for that one. Okay, I'm going to do one of these with you, kind of talk about what we're looking for. I kind of listed them out yesterday. The things that we want on all 3 of these graphs. Obviously, one would graph it, but in order to graph it, we want to determine, does it have any vertical asymptotes or holes? What is the horizontal asymptote, or does it have one? And then where does it cross the x-axis and y-axis? And like I said yesterday, it may not have all of those things. You may say it doesn't have a horizontal asymptote, or it may not have an x-intercept. So it doesn't have to have all of those things. If it doesn't, just say none. There is no x-intercept, something like that. Okay, so I'm going to kind of walk you through kind of what we're going to look for here. Okay, vertical asymptote and holes is where I'm going to start. Okay, there is no hole here because you have to have a common factor. Top and bottom have to have the same factor. We do not have the same factor here. And as we talked about on the notes when we did this lesson, we don't have holes very often because very seldom do you have a common factor on top and bottom. But if you do, we got to put a hole into the graph. My vertical asymptote would be x equals -3. We're going to set the denominator equal to 0. And it's just a one-step equation in this case. Okay, the horizontal asymptote, the degree on top and bottom is both 1, right? So here the degree is the same on top and bottom. So we go back to that rule we just talked about. If the degree on top and bottom is the same, then we're going to divide our leading coefficients. So it'd be 1 over 1, or just y equals 1. Okay, so the first thing that I'm going to do is I'm going to put those asymptotes in here. Y equals 1. X equals -3. Those are the two lines that the graph should approach. Okay, x-intercept. We're going to set the numerator equal to 0. So that would be x equals 2. So it's going to cross the x-axis at 2. My y-intercept. You could get the y-intercept off your calculator. I don't have a problem with that. If I plug 0 in for x, what's my y value? But really here it's not too bad to do by hand. 0 minus 2 is -2. 0 plus 3 is 3. So really it's just -2 over 3. And that would be my y-intercept, -2/3. So that would just be between 0 and -1. Okay. And really, I'm not looking for like a table of values here. I mean, if you want to make a table of values, then go for it. But I'm just trying to keep it as simple as possible. The asymptotes are going to kind of show me what the graph is approaching. And then when I put this into my calculator, it should use all of those things and kind of tie all that together. And when I graph this, going to have two different branches in opposite corners from one another, basically. Okay, and that's what I'm really looking for on that. The asymptotes are a really big part of it, so we definitely want to identify the asymptotes. The intercepts, you could get the intercepts from your calculator, okay, either both the x and y intercepts. But remember, it may not have both. It may not cross the x-axis. It may not cross the y-axis. Okay. I'll let you do the other two. I just wanted to kind of show you all the different things that we're looking for there. On 22, you're going to have to factor this, kind of like we talked about a few minutes ago. I tried to keep the factoring pretty simple on the test. You might see DOPS, you might see GCF, you might see product sum. This would be a product sum factor. I don't think there's any slide and divide on here. I could have been real mean and put a slide and divide on there. Okay, no questions on that page? All right, last one. Okay, we want to find out when is this function greater than 0. Okay, now a couple of different ways that you can do this. You could just put it into the calculator, right? And I don't have an issue with that one bit. These are the two places that should cross the x-axis, okay? Now, can I just get that from my calculator? Yeah, you could, okay? And I don't have an issue with that. But factoring it and then knowing where it crosses the x-axis is kind of a big deal, okay? So then what we're going to do here is pay attention to the symbol, okay? What inequality are we using? And so I want to know, when is this going to be above the x-axis? Well, if I graph this one, these are the two places it's going to cross the x-axis, and I'm just going to do a real quick sketch here. Okay. I don't even really care what the graph looks like too much. Really, we're just paying attention. Does it open up? Does it open down? And when is it above the x-axis? So it's above the x-axis to the left of -7 and to the right of 2. And then we want to decide, are we including -7 and 2 or not? Well, if it was equal to, we would include it, right? But this is not, it's just greater than. So we only want to know, when is it positive? And so from -infinity all the way up to -7. And I'm going to start over again. Should be, I graphed it wrong, didn't I? Darn it. This should be, because it was x equals -2 and x equals +7. So that's my fault. So all the way up to -2. And then everything from 7 to infinity. And if I had changed this to less than instead of greater than, it would be everything from -2 over to 7. And so just the symbol, it makes everything. It's the difference between everything there. Okay, 24, just solve it, okay? Set it equal to 0, get everything together. They already graphed it for you, so you wouldn't even necessarily have to do that. It tells you where your x-intercepts are at, so you're really ready to go here, okay? -5 and 2 are the two places that it's crossing the x-axis at. Okay, and then we did a couple of quick critical value questions when we did this. Critical value is really just, what value of x can we not have? Which value of x would be critical? Which value of x gives me a denominator of 0? So x cannot be 7. That's a critical value. Because 7 would give me 0 on bottom, and we know that can't happen. So that's what makes it critical. So just be really careful here. Like this one has x equals 7. This one has both. This one has just -7. This one says there's no critical values. So by process of elimination, the only one that could be is C. Okay. You could still go ahead and identify what the solution is, what they ask us for, but there's only one answer that has the correct critical value. Okay. Any other questions so far?
It was A?
26, C. Because 7's the critical value. So C is the only one that has 7 only as a critical value. This one had no, this one had both -7 and +7, and this one had -7.
Okay.
The second part of that, after the semicolon, is the actual solution. So you're gonna find the critical value, and then you're gonna find the solution. So that's why there's two parts to the answer. Okay.